Hi, my name is Leandro Facchinetti, and let's write some code together, shall we? What we have on the menu today is, well, it was supposed to be the tone generator. I promised that in the previous video, but actually in the comments for the previous video, there was this very helpful person who watched the video very carefully and caught a huge mistake. So we are going to revisit the bit crusher yet again for the third and probably, that's what I hope, the last time, and fix this mistake. And we will also do something that I promised I would when we added multi-channel support for the oscillator, but I forgot to do it, so we are going to do that now. So let's go to Reaper, and first I'm going to do the thing I promised I would do with the multi-channel oscilloscope, and that is to look at the effect we created before to burn-in the speakers. So I'm going to mute the master track, and I'm going to bring in the burn-in speakers effect. And if you don't remember, that effect is supposed to generate white noise that is exactly the opposite or exactly out of phase on the left and the right channels. And I said I would demonstrate this when we had a multi-channel oscilloscope, which we have now since the previous session. So we can come here to the oscilloscope and let's make this big and zoom all the way in. I know the slider is under my face, but the point here is that we are going to zoom somewhat and then pause and then look at the shapes of the blue left channel and the red, the right channel, and they are exact mirror images of one another. So the burn-in speakers is doing what it's supposed to as promised. Okay, with that out of the way, let's go to the bit crusher. So for this, I definitely want the tone generator. We will create this in the next episode, I promise. And then the bit crusher, like we left it last time. And then the oscilloscope right after that. And I'm going to play so that the oscilloscope is capturing. And we have the tone, which is a sine wave. The bit crusher has such a high resolution that we are actually seeing the sine wave more or less intact. Like so. Good. Now we are going to leave the oscilloscope open here and come here to the bit crusher and look at the cases where the bit is there's only one bit. And then, yes, when you have only one bit, you are supposed to have only two states on or off. And then we only have two states here, so I claimed that this was correct, but it's not, it's incorrect. And I want to thank Ash Blackwater for figuring out the mistake here. In fact, when I was programming this, I thought it was kind of weird because the code I wrote with this +1 was not matching the code that I have previously investigated, but I thought, well, you know what, no problem. In fact, there was a problem. And the problem is that I'm generating the tone at -12 dB. So when I'm generating the tone, it's not using the full resolution. And then when I bit crush, I am bit crushing just that part. So I am actually giving more resolution than I should to this. In the bit crusher, I'm giving more resolution than I should to the signal. So to actually exercise this, I'm going to turn off the bit crusher for a moment, and you can see that it's going here up and down, but it's not covering the whole spectrum. And you may remember when we are creating the oscilloscope that we had 1 as the top of the screen and -1 as the bottom of the screen. So we want to use the full resolution. And to do that, I am going to put the wet mix at 0 dB. And now it's using the full resolution. And then when we turn on the bit crusher with 1 bit, it was supposed to only give you actually two states, 1 bit, right? So either 1 or 0, and that is either top or bottom. But it's giving a bunch more. I think it's giving like 8. I can pause and check, but I believe it's giving 1, 2, 3, 4, 5, 6, 7, 8. Yeah, so that's off. So let's play again and come back to the code for the oscilloscope, the code for the bit crusher. It's actually wrong to add 1 here. So if we don't add 1, we get closer to the answer, but actually, if we subtract 1, then we get the right answer. So instead of adding 1, I should have subtracted 1. That's the mistake. So Ash, again, thanks. You said that the bit crusher was not actually off. It was off, but for the wrong reason. So I got it inverted. But that is now correct. And yet, there are a few more things I want to do. Since I'm here, I always find more things that I want to do. I actually want to fix two things about the bit crusher. The first is you can see some spikes here that go to 1 from time to time. I can pause and maybe I can catch one of them. So right here, I have one of these spikes. What's happening here is that at this point, the sine wave, the original one, was actually going to 1, exactly 1. And when it does that, the formula here is going to be, well, the sample is 1 times the bit reduction factor, that is, in this case, I have 1 bit, so it's 1 minus 1, 2 to the power of 0, that is 1. So I'm actually multiplying 1 by 1, that is 1, and then I take the floor of that, which is 1, and I divide by the bit reduction factor, which is 1, so then I end up with 1. So when the sine wave is exactly 1, I am outputting 1, just for that one sample. And that spike may be a click, or you may not even be able to hear it at all. I didn't try to actually hear it, but I know it's wrong, because if you only have 1 bit, you should only be able to represent 2 values. And the other thing I don't like about this is that the 2 values are -1 and 0 in this case. And it falls out from the formula I'm using to do the bit crushing, that I am taking the floor of the numbers, I'm not actually rounding. So I'm always truncating values down. So if you have a number like 0.7, it's truncated down to 0. And of course, -5 is truncated down to -0.5 is truncated down to -1. What I would like to happen is to truncate, or not to truncate values, but to round them. So 0.7 goes to 1 and -0.5 goes to -1 in this case. And of course, if you have more bits, then the resolution will be higher, and it's kind of harder to think about this, but the principle remains. I want to do rounding instead of just truncation. So let's work this out. And I'm going to do this only with the oscilloscope. I'm not even going to hear this because I know what I want the wave to look like. And then we may run some examples through just to see if it still makes sense. But in this case, that I only have 1 bit, the values, the samples should be either -1 or 1. I want to use the full resolution that is available to me, and I want to do that with as many bits as I have. So if I only have 1 bit, I go from -1 to 1. And let's just work this out, okay? So I will remove this bit reduction factor. In fact, I will remove the whole formula, and we are going to start from scratch. So if I just don't do anything to the wave, now this is a bypass effectively. I can play here, and we see the shape of the sine wave that we are working with. Now, let's make these values that are between -1 and 1, let's transform that range to between 0 and 1. So we are going to normalize the sample. So I'm going to say that this is the sample, or I'm going to call this normalized. Since this effect is so short, I'm not going to say effect. I could say something like sample normalized, but this code is so short, I'm just going to call this normalized. Or maybe I'll grab the sample, and then I'll say normalized is, well, the sample ranges from -1 to 1 in the best case scenario. So I'm going to do this. And then I can paste this chunk and here different parts of the chain, because I'm going to create a chain of assignments here. So currently I am doing the tone generation. I'll bring in the tone generator here, and I'm doing the tone generation at 0 dB. But I could go over and generate at 1 dB, for instance. Or actually, I'll put it at 5 dB, so it becomes very clear what's going on here. So we are clipping. Now we are going over. We can zoom out and still see the full wave, but we are clipping. And how come we can see the full wave if we are clipping? Well, internally, Reaper keeps track of the samples with a higher resolution. It doesn't allow only values between -1 and 1, but also allows values like 1.7, like we just saw, or -1.7. So it allows values greater than 1 and less than -1. So first thing I want to do is to clamp the values, and this is similar to, in fact, it's exactly the same as what we did in the limiter, the hard clipper. You can go watch another episode in this series in which I create a bunch of effects in very little time. One of the effects was a limiter, and we're going to limit this so we are only working with values between -1 and 1. And why is that? Well, we're going to do a bit crushing eventually, so we don't have enough bits to spare in the resolution between -1 and 1, let alone values that are higher than 1. I don't want to waste bits with those values, and I don't want them to show up at all. So I'm going to clamp the sample as the first step. So I will say that this is clamped, and I'm going to take the sample. I'm going to take the maximum between -1 and the sample. So that is going to be, if the sample is in the range of -1 and 1, then that doesn't change anything because the maximum between -1 and something like 0.7 is 0.7. But if the sample is below -1, so if the sample is like -1.3, like just showed up, then the maximum will be -1. And the minimum between 1 and the result of this part. So now we are taking values. The logic here is similar. If the sample is 1.2, then the minimum between 1 and 1.2 is 1. But if the value is something like -0.3, then the minimum between 1 and -0.3 is just -0.3. So the clamped value is the sample in the range, guaranteed to be in the range of -1 and 1. So when I save this, and I can even zoom out, and this time you can see that the wave really is being chopped off. We are doing some kind of limiting here, a hard clipping. Now the values are guaranteed to be between -1 and 1. Now let's normalize this, and by normalize, I mean we are going to take values that are between -1 and 1, and we are going to make them be between 0 and 1. So values between 0 and 1. So what we need to do here is first take the clamped value and add 1. Now the values are between 0 and 2, and the result of that, we divide by 2. Now the normalized values are between 0 and 1. I can even zoom out, and I'll see that there is no going over here. The values really are between 0 and 1, and I can even see that it's drawing something here, so it's exactly at 1. Now, let's take this value that is normalized, and we are going to multiply by our resolution, by the number of bits we have available. So if this value is between 0 and 1, I want it to be between 0 and the number of bits we have available, or the values that we can represent with the bits we have available. So in this case, I don't think I have a good variable name for this. I would just say in resolution, because that's our value in the resolution. Or maybe I would just call this the truncated. How about that? We are going to be truncating the values or rounding, maybe rounded. I'll call it rounded. There you go. So I'm taking the normalized value and I'm multiplying by the number of bits, or 2 to the power of the number of bits. So let's think about this. I'm taking a value between 0 and 1 and multiplying by 2 to the power of the number of bits. So if I have something like only 1 bit, I can only represent 2 values, 2 to the power of 1. If I have 2 bits, I can represent 2 values because each bit can represent 2 values, and I have 2 of them, so 2 times 2 is 4. If I have 3 bits, then I can represent 8 values because each bit can represent 2 values, 2 times 2 times 2. So it's 2 to the power of bits. And if I just do this multiplication, then I will have a value between 0 and, for instance, in this case where I have the bit crusher is set to 1 bit, I will have only I'll have only 2 possibilities. So I want this number to be between 0 and 1, right? Between 0 and 1. But this multiplying by 2 to the number of bits, that's 2 to the power of 1, which is 2. So this is multiplying by 2. So what I want to do is actually take 1 off. So I'm multiplying by the number of bits, 2 to the power of the number of bits, minus 1. So now this is not going between 0 and 2, but between 0 and 1. And then I can round things. So this is now a value between 0 and 1, and I want to round. Well, I wish I had something like round, but as you can see by the faint color of yellow here, there is no round function in JSFX. There is floor, and there is sail for ceiling, or If you have something like 0.3, it will round up to 1. But there is no round. But there is a trick. If we take the floor, but before taking the floor, we add half, then if you have a value like 0.3, it will be 0.8, and you take the floor, it's 0, same. But if you have a value like 0.7, then you add half and you end up with 1.2. You take the floor that and that's 1. So effectively, adding half and then taking the floor is rounding. Unless you take in account some edge cases that I don't care about. So yeah, I'm just going to say that this is taking the rounded value. So this is now a value that is guaranteed to be an integer because I'm taking the floor. So that's guaranteed to be an integer. And it's either going to be 0 or it's going to be 1. So now I save, and this value is between 0 and 1. And actually there is a ramp up. Oh, there is a ramp up because I am not saying that I want to look at the rounded value. So, okay, now I saved this. This is a value between 0 and 1, as we can see here in this drawing. Now I have a value that is rounded, but it is between 0 and 1 in this case because I only have 1 bit. But let's increase this to have 2 bits, and you can see that it's going over. I will have to zoom out, and you can see that it's definitely going over 1. And that's because if we have something like 4, in this case, we can represent 4 values with 2 bits. I have numbers going between 0 and 3. I'll pause this for a moment. 0, 1, 2, and 3. We have values going between 0 and 3. So that's not exactly what I want to do. I want to divide this result by this, which is what we multiplied to begin with. So I'm doing multiplication and then truncation and then division to get back where I started. So now this value that is rounded, I can save this. Now this is between 0 and 1. As you can see, I have 4 values, 0, 1, 2, and 3, but they are all between 0 and 1. So this is probably like 0, 0.25, 0.5, and 1. Now I have a value between 0 and 1. That is exactly the shape of the wave I want, but I want this shape to be between -1 and 1. So I'll have to undo the trick I did here when normalizing. I'll have to take this rounded value and round it, and I'll have to multiply by 2, and now I have a value between 0 and 2. And then I will subtract 1, and I will have a value between -1 and 1. So I'll take this like so, save, play. And now we have 4 values because I have 2 bits. I have 4 values and they are between -1 and 1. So this is probably -1 and -0.5, 0.5, and 1. No, I guess it's like 0.25. Yes, it's like -1, -0.25, 0.25, and 1. Probably these are the values. And of course, if I take this, I'm going to play the oscilloscope, come here to the bit crusher, and decrease the number of bits to 1. And now the values are between -1 and 1. And there is no weird spike. There is no values that could go over, guaranteed never to go over. And you can see beautifully here the samples toggling between -1 and 1, occupying the whole range. And if I come back here to the tone generator and bring it down, then even if the signal is very quiet, I'm going to turn off the bit crusher for a moment. So I have this big wave like before, and I can make it go up to 6. Yeah, awesome. So I can bring it down, and the wave is very faint. Now this is super quiet. But if I turn on the bit crusher, then it gets super loud. And that's because every time you are above 0, with only 1 bit, you are rounding up to 1. And if you are below 0, you are rounding down to -1. So this would be super loud. It's a good thing that we have here our master muted, because we definitely don't want to hear this. Even a faint, very quiet signal turns super loud when you turn on the bit crusher that works like this, rounding the values. But I still think that this is the correct thing to do. I think that's like the canonical idea of how the bit crusher should work. That's not, in fact, and that's a curious thing, that's not how the bit crusher that comes with Reaper works. So I can come here to the one that comes with Reaper, bit reduction, and look at the source code. And well, I can look at the source code and I can show you that it's doing the truncation, but it's not exactly doing the whole rounding thing I showed you. So it's not behaving exactly the same. But the point I wanted to make here had to do with, it has this gain thing. And that's what we want to do. We want to have, you know what? I'm going to show you that the bit crusher that comes with Reaper doesn't react the same way that our bit crusher does. So I'll bring down the number of bits down to 1. And you can see that it's all over the place. It doesn't have a beautiful square shape like that one we have. And I think that our version, or I should turn off D3. Yeah, it doesn't have that beautiful shape. It has these other shapes, but it's not rounding up to 1. It's not occupying the full resolution. And the way this one works is similar to the one we had before, but with the fix I showed you in the beginning, -1 instead of +1. So if you just use that formula from before and use -1, the correct one, you end up with an effect that looks like this one. It's okay, but I don't quite like it because I think that this one, the one we have right now, really represents the essence of the bit crushing. But it's too loud. It takes a signal that is quiet and makes it loud. So I'm going to just add a gain knob. This is similar to the other video in which we created a gain effect, and in that one I explain everything about the formula to convert between dB and amplitude and vice versa and the whole background. So if you're interested in learning how this works, then you should check that other video. It's like the simplest effect you can create in detail. That's the name of the video. Now we want to have a gain set in dB that will start super quiet, so maybe like -18 to begin with. I will allow you to go from -60 up to 0, so you cannot increase the gain greater than 1 using this plugin. And I'll give you steps of 0.1 dB. And this is going to be the gain in dB. And I'll have here a slider section in which I compute the gain in amplitude. And I'm going to use the weird formula I explained in the other video, which is 10 to the power of gain in dB divided by 20. And here, when I'm doing the output, I will multiply by, well, I'm considering if I should assign this to a separate variable. I guess I will. So I don't know exactly what to call this other variable yet. So if that is rounded, that is, I don't know, the crushed sample. There you go. And then I'll take the crushed sample and multiply by the gain in amplitude. And this starts at -18, so we can go up to 0, and then it becomes the real deal, the real wave, but we can bring it down so it's not that harsh. So we can do the bit crushing. It's a very hard bit crushing because we are only using 1 bit, but still it's not too loud. And another thing I want to do is, since I have this formula that I can just plug in any value as the number of bits, I have the number of bits, I allow you to give non-integer bits, which is super interesting. I don't think that many bit crushers allow you to do that. But we can go below 1, and that also works. You can go below 1. You cannot go to 0, though, mind you, because 0 bits means that you would have 2 to the power of 0, which is 1, and then 1 minus 1, which is 0, and then division by 0 is not a good idea. It still works in JSFX. Dividing by 0 is 0, and that just turns out to work on my machine. I don't know if it works on every machine. I know that it's like called unspecified behavior. That's how it behaves on my machine. It doesn't crash or anything. I don't think there is a way to crash a JSFX at runtime. If the code compiles, it's going to do something. Anyway, so we have that, and now you have control over the number of bits, and you can go below 0 or below 1. And I guess to show this, I'll have to make the wave. Oh no, look at that. So if I go below 1, it behaves super weirdly. I don't know what's happening here. I did a full compile reset. Maybe that works. And I also want to increase the gain so I can actually look at the shape of the wave. Okay. Yeah, this is super crazy. If I go below 1, it goes crazy. Oh, it gets really loud too. So maybe that's that. I have to zoom out to actually see the wave. Yeah, if I zoom out vertically, then I can see the shape of the wave. And this is probably like some unusable thing that doesn't sound good at all. But still, it's a possibility, and now you have it. And yeah, I want to create a wave that is with the tone generator. That now that I have a gain knob, I want the wave to go all the way up to 0. And I want to bring the gain up. And this should, if I have 16 bits and I don't affect the gain at all, and I am using the tone generator to produce a wave that is at 0, then I can have a, yeah, now I am zoomed out, or zoomed in anyway. I have a neutral zoom here of 1, and I can see the shape of this wave as I reduce the number of bits. It's changing beautifully. And I can go below 1 and it's reacting somewhat sanely. Yeah, but it's definitely going over. So this is, I have to zoom out to see the full shape here. It's definitely clipping. And we can see, in fact, that when I go below 1, this is going to like plus 9 dB. So it's adding dBs to the story. But anyway, it's something you can do, and it's super gradual. And when I get below here, I guess it may get too loud, and then Reaper just it stops processing. I don't know what happens, but still, you can go below 1 if you want. Now let's give this a listen and see what it sounds like. I definitely want the tone generator to be generating a sine wave that is at 0 dB, but I want the bit crusher to be way quieter than that. So I guess this may be good enough. I put on my headphones and I will turn on the audio. Okay, I hope I got this right. Let's hear this. Okay, so it's not sounding too harsh. And then I would decrease the number of bits and we'll hear the clipping or the bit crushing. Did you hear that? And also did you see that? I'm going to zoom in here. It's super fun. When I reduce the number of bits below 1, then what was just a square wave when the number of bits is equal to 1, then you have exactly a square wave. But when I go below, it is a square wave still, but it's louder, and it changes the width of the wave. So you can see that effect here on the oscilloscope. And I could also hear that. I'm going to turn this on again. And then when I go to half, it just blows up. I have no idea what's going on there. But this was super fun. We can have something like 0.8 or 0.7 bits, which is complete nonsense, but it still sounds crazy and cool. And here, when I have something like 2, I have exactly 4 steps. And when I have 3 bits, I have exactly 8. In fact, I want to make sure that I have this right. So I'm going to zoom in and pause and maybe zoom in this direction as well and count. So I want to make sure that I have 1, 2, 3, 4, 5, 6, 7, 8. And let's put this to rest, okay? The Bit Crusher now is working. It is doing what it's supposed to. No more bugs on this one. At least that's what I hope. Anyway, thanks for watching this. If you're interested in these kinds of videos with programming and interesting Reaper stuff, I will also do non-Reaper programming in this channel. But anyway, if you're interested in these kinds of things, make sure to subscribe to the channel. Thanks for watching this one. Thanks again to Ash Blackwater. Thanks for finding my mistake and giving me a hint on how to fix it. And that's all I have for now. Thanks. I see you on the next one. Bye.